Okay, I guess we can get started. Welcome everyone to our webinar. My name is Daniela and I am at the CMCC, and I'll be starting giving just a short presentation on the webinar and the project that in our institute and the project that organized this webinar. And then I'll pass to our great panelists today that are going to talk about bioenergy with carbon capture and storage. Just to give you an overview of this webinar series, this webinar series is organized by the Industrial and Planetary Carbon Cycle at the CMCC, and is part of this UPTAKE project. And the idea is to promote knowledge sharing and discussions about the latest developments of a variety of carbon dioxide removal technologies and science. So it happens every second Wednesday of the month, and always at 2 p.m. at the Central European Time. Registration is required, so I encourage all of you to follow the news on the next events. So you can follow on LinkedIn. You are in the mailing list. I'm going to be receiving all the next webinars. So just to give an overview about CMCC, CMCC is a leading research center in Italy, which is focused on understanding the interaction between climate change and society. So we're about 450 researchers and staff across 3 institutes and 3 research centers all over Italy, as you can see here in the map. And we have 3 main institutes, as you can see here in the bottom. One is related to climate predictions and climate science. One is more on the question of adaptation. And the one here, the EIE, that's the European Institute for the Environment and Economics. It's the one in Milan. It's the one that organizes those webinars. And also within CMCC, we have 3 cross-cutting programs. One related to the global coast as a new frontiers. The other one is predicting socioeconomic impacts of climate change. And the ICC, that's the integration of the planetary and industrial carbon cycle, is the one that also organizes this webinar. And as part of this institute, we have this UPTAKE project, which it is a European funded project, with the goal that's to bridge the knowledge gaps to enable the uptake of carbon dioxide removal methods. And part of this project is to organize this webinar just to give some outreach of the latest research that we develop. And this project started in 2023, and it has a duration of 4 years. It involves more than 20 institutes across Europe and the United States. And as part of this project, we also developed the CDR Forum, which is a platform that the idea is to engage better with different stakeholders from different communities. And you can also be part of that. So if you want to have a chance to interact with the consortium members of the UPTAKE project, as well as with other stakeholders, you can just scan this QR code and fill a very short form, and then you are going to be part of this forum, and then you can interact with all the other members there. And with that said, I want to introduce today the theme of this webinar, which is going to be to talk about the quantifying the climate change effects of bioenergy and BECCS. And we have a great panelist. The speaker is going to be Annette. And then this discussion is going to be moderated by Elidi from DRAX. And we also have a panelist, Stefan from DBFC. So with that, I will pass it to Elid to start the presentation and the moderation. Thank you.
Thank you so much, Daniela. Hello, everyone, and thanks for coming today. I'm really pleased to be here joining as a moderator. And my name is Ailey Forster. I have a background in forestry value chains life cycle assessment. I work for DRAX, a renewable energy company based in the UK, and it operates the Bioenergy power plant as well as wood pellet facilities in North America. And we're also looking at developing BECCS opportunities in the UK and internationally. So this theme and webinar is very much within my interests and the interests of the business. So we'll start the webinar today with a presentation from Annette. It will be around 15 minutes or so, and then that will follow by the live panel discussion, where you will have a chance to submit questions for the speakers in the Q&A section. So I'm very pleased to introduce our presenter and panelists, Annette Curry and Stefan Meyer. So I'm just going to hand over to each of you to make your own short introduction, starting with Annette, please, if you wouldn't mind.
Thanks very much, Ellie. Yes, I'm Annette Cowie. I'm from the New South Wales Department of Primary Industries and Regional Development in Australia, where it has just gone midnight. So I hope to stay awake and active for this presentation. And thank you very much to the organisers for inviting me to present. Should I start my presentation now, or did you want Stefan to introduce himself as well?
I was going to suggest Stefan just make a brief introduction. That way we can keep the flow maybe after the presentation straight into the panel discussion.
Sure, that's fine, and I'll make it very brief. Thanks a lot for inviting me. Thanks, Alice. I'm Stefan Meyer. I'm with the German Biomass Research Center, where I am a researcher and LCA practitioner. And I'm also working a little bit on the interface between producing LCAs, but also using it for policy advice. And I also have the pleasure to, together with Annette, to work in IEA Bioenergy Task 45. So it's a pleasure to be here.
Brilliant. Thank you both for those introductions. And without further ado, Annette, I'll pass over to you to make your presentation.
Thank you, Ellie. Hopefully it is sharing.
It's working, yeah, all looks good.
Excellent. Well, as I said, I'm Annette Cowie from the New South Wales Department of Primary Industries and Regional Development in Australia, and I'm the Australian representative on Task 45. So I'm going to be presenting some work that was recently published by IEA Bioenergy Task 45. In case you're not aware of IEA Bioenergy and our task, it's a knowledge exchange network under the IEA Bioenergy Technology Collaboration Program. And our task focuses on climate and sustainability effects of bioenergy within the broader bioeconomy. And I'm going to be talking about the recommended methodology that we've recently published for quantifying climate effects of bioenergy and BECCS. And I'd like to, in particular, acknowledge the members of Task 45 who are co-authors on the paper. My slides will progress. There we go. As you are probably aware, bioenergy is a component of many national climate change policies. It's been adopted by countries to meet their targets under the Paris Agreement. You're probably aware that the Paris Agreement seeks to limit global warming to well below 2 degrees, and it recognises that to achieve this goal, the world needs to reach a position of net zero greenhouse gas emissions in the second half of the century. So that's a condition in which greenhouse gas emissions are balanced by greenhouse gas removals, and bioenergy can contribute to both sides of that balance. Just to make sure we're all on the same page here, biomass, of course, is derived from plants. As plants photosynthesize, they take carbon dioxide out of the atmosphere and they convert it to into sugars and complex carbohydrates that make up their biomass. So biomass stores carbon from the atmosphere. When it decomposes or is combusted, the carbons return to the atmosphere. And bioenergy is renewable energy if the biomass is regrown. So the CO2 is the same, whether it comes from coal or whether it comes from biomass in terms of its impact on the atmosphere. So while bioenergy emits CO2 at the point of combustion, the key difference between bioenergy and fossil fuel is that bioenergy operates within the short-term carbon cycle, whereas fossil energy systems transfer, transfer carbon from where it's safely stored underground into the atmosphere, where it essentially causes permanent warming. So bioenergy is a renewable energy source that can displace fossil fuels, and it's carbon neutral within the biogenic carbon cycle as long as the biomass is regrown after harvest or obtained from residues that would otherwise decompose to atmosphere or be burnt to waste. But of course, it's not entirely neutral because of the use of fossil fuels in the supply chain. Bioenergy plays a key role in all the strategies that the IPCC has identified that meet the temperature goal of the Paris Agreement, and it contributes up to 30% of energy supply by 2050. And similarly, in the IEA's net zero emissions scenario, it indicates a key role for bioenergy across all sectors, including biogas and liquid fuels. But on the other hand, you may have heard claims that bioenergy is actually not useful for climate change mitigation. There are even headlines that suggest that bioenergy could be worse than fossil fuels. And this, of course, is quite confusing to policymakers to understand why this quite divergent view out there about the potential impacts of bioenergy on climate change. And this is where Task 45 steps in. It's providing guidance to interpret this divergence in the scientific and popular literature. Now, there are many different types of biomass feedstocks that can be used for bioenergy. There's a range of them illustrated here, from manure to crop stubbles and purpose-grown biomass sources, residues from forestry, etc. Each of those has different properties when used for bioenergy. And then there's a range of different technologies that can be used to convert that feedstock into bioenergy products. And so that ranges from combustion, pyrolysis, gasification, fermentation, anaerobic digestion, etc., some of which are illustrated here. And then there are a range of different products and end uses that you can apply. So you can have solid wood products like pellets and wood chips. You can have liquid fuels, ethanol, biodiesel, renewable diesel. And then there's the gaseous products, biogas, biomethane. You can pyrolyze biomass and produce bio oil and syngas and biochar at the same time. And you can use those products to supply heat, electricity, transport, and it can come in a wide range of scales, from small cook stoves through to processing plants that deal with tons per hour. And because it's so diverse, it's not actually surprising that there's a range of results and when you look at the impacts of bioenergy on climate change mitigation. This figure is illustrating the range of results for the emissions saved for a number of different supply chains, showing that when you use the biomass for simple systems, when you're supplying heat, it tends to save more emissions than when you have a process that's perhaps more complicated, like turning the biomass into a liquid biofuel. So the results differ due to the very wide range of biomass systems, due to the differences in the feedstocks and the technologies and the products. But the results can also differ between studies due to the analytical methods chosen by the researcher. And sometimes that can lead to very different results when exactly the same bioenergy system is analysed in different studies. And often this is a subjective choice by the researcher, and it can reflect the different perspectives, for example, between different disciplinary traditions or different worldviews. You can have different methods that can be that can be applicable for different applications. So Task 45 is trying to help people to work out which is the appropriate method for their particular circumstance. And actually, the Task 45 and its predecessors have been operating for about 25 years and producing papers and fact sheets and journal publications over that period to help people understand appropriate methodology and its interpretation. We first developed a standard methodology, in fact, the first one was published in 1997. And so our paper now is actually updating this original paper. And it's really much the same. Nothing much has changed in the understanding of how you should assess the climate change effects of bioenergy. But the two more recent papers that we have produced, firstly, this one published in 2021, that was really a myth-busting type of paper, and then the one that we've just published this year, both talking about how you need to look at bioenergy from a whole systems perspective and look at the whole life cycle. So that most recent paper is the main focus of the remainder of my talk. As I mentioned, we're looking at a life cycle perspective to quantify the climate change effects of bioenergy. So we're looking at quantifying the emissions all the way through the supply chain. We're considering any fossil fuel inputs and fertilizer inputs, for example, to agricultural production, transport, processing, emissions from wastes, and we're adding all those up across the life cycle. A key choice to make is the modelling approach, and that depends on the purpose of the assessment. So there are two key modelling approaches that are used in life cycle assessment, and the choice really depends on the purpose. If you are undertaking the study in order to inform policy development, such as to determine whether a certain bioenergy supply chain should be eligible for policy support, it's critical that you consider the effects, including the indirect effects, of expansion of that bioenergy supply chain. And therefore, it's important to use a consequential approach. On the other hand, if you have a routine policy implementation, such as for companies demonstrating that they meet the requirements of a certain threshold for an existing policy, then an attributional approach, which focuses on the direct effects across the supply chain, can be adequate. An important choice is the scope of the emissions sources and sinks included. So this one's talking about choosing the appropriate biomass carbon pools to consider. Quite often soil carbon is left out because it's kind of difficult to quantify, or it can be important depending on whether you have a land use change or a land management change that influences soil carbon stocks. Illustrated here would be a direct land use change associated with replacing a high carbon stock forest with an oil palm plantation. And here you definitely have a change both in the vegetation and in the soil carbon stocks. And that needs to be included when you're quantifying the carbon footprint of the palm oil. But the previous land use is critical to the result. If you're planting into degraded land, you might find that you're actually increasing the carbon stock when you replace a low biomass production system with one which has a higher net primary production. A second aspect of the scope is which greenhouse gases are included. Obviously, we include CO2, but it can be very important to include non-CO2 greenhouse gases. This example shows the contribution of nitrous oxide to the carbon footprint of sugarcane-based ethanol in Australia. The pale green parts of the bars represent the nitrous oxide, and you can see that it's actually the dominant source of emissions. That's because in this warm, moist environment where sugarcane is grown in Australia, there's a very high emissions factor for the nitrogen fertiliser applied. Another important aspect of the system boundary is the spatial scale. If you look at a single forest stand, you'll see quite divergent range in the forest carbon stock as you go from planting through to harvest. However, a forest is actually managed to provide a constant supply of timber. So generally, a forest is managed as a series of stands of different ages. And if you look across the landscape at the whole forest estate, you'll see that actually, if you have a sustainable harvest, you have a constant carbon stock across the whole forest. So the scale of assessment really matters. The top graph shows the single forest stand where you see the typical sawtooth pattern. And then at the bottom, you're seeing at the landscape scale with the blue line, whether you have a sustainable harvest where you're not actually changing the carbon stock across the whole forest. If you then introduce a system where you take more of the biomass out to meet your bioenergy demand, then you might reduce the carbon stock in each stand, and that might look more like the red line. On the other hand, you might introduce improved forest management and follow the green line instead, or even the purple line. But essentially, you will not see that sawtooth pattern if you're looking at the whole forest estate. If you have changed the management so that the carbon stock's reduced, then that is a quantity of emission that you need to allocate to your products. Another important issue is when you start the clock. This is critical for longer rotation plantations. If you start counting at the point where the trees are harvested, you start with a large emission. Whereas on the other hand, if you start when the trees are planted, they first take the CO2 from the atmosphere. So you'll have a negative emissions phase before the CO2 is returned to atmosphere. Another important thing to consider is the metric that you use to assess climate change effects. The most common metric that we use is the global warming potential over 100 years, which is applied to the cumulative emissions across the whole life cycle. However, there are various other impact assessment methods that have been published. This paper compared 15 of them and found that they can give quite different answers, and the degree of difference depended on the system that we were modelling. If it was energy crop replacing a forest, then it had a big impact. But if it was an energy crop replacing another annual crop, then there wasn't much difference between the different methods. In our paper, we recommend applying a method that does recognise the impact of timing of emissions and sequestration, such as the climate change impact potential method, or we suggest you could alternatively calculate the cumulative radiative forcing over a relevant period, or you could apply the recommendation from the UNEP Life Cycle Initiative, which is to use multiple metrics. They suggest using the GWP 100 and the GTP 100 to capture the longer and shorter term effects. Another important thing is handling co-production. Many of our production systems actually have co-products, and we, in our methodology, followed the ISO guidance for LCA, which says that where possible, you should avoid allocation by subdividing your system if you can determine the different inputs that go to the different products, or alternatively use system expansion with substitution in order to identify the particular product you want to determine its emissions intensity. If you don't do that, then you can apply allocation. And in that case, you should preferably be sharing the inputs and outputs based on an underlying physical relationship. Otherwise, you could use a straightforward relative mass, energy, or economic value. In our methodology, we're actually aligned with a consequential approach, and so we provide some guidance on how to apply the consequential approach in looking at product allocation. So in this example here, you're trying to determine the emissions intensity of product A. Your co-production system produces products A and B. Product B in the market displaces product C, which is functionally equivalent. And so you subtract product C from your total product system in order to estimate the emissions from product A. Now, this is just a little example that I thought might be useful to show. This is a paper that was published looking at an ethanol system where they were modelling the potential for introducing BECCS, so capturing the CO2 from fermentation and using that for geosequestration. And so they have applied a system expansion approach to determine the emissions intensity of the ethanol produced in this system. So the co-products that they were looking at were corn oil and the DDGS, which is used as an animal feed. And so they determined the emissions intensity of the ethanol for the three different configurations that they were modelling. But they didn't consider the emissions of, they didn't consider the CDR to be a product or a service of this whole production system. So interestingly, some other researchers looked at this data set produced in this paper, and they added up the supply chain emissions, and they said, well, actually, there's more emissions than the amount of carbon removed in the CDR component of this system. And so they said, well, this isn't even a carbon negative system. But the point was that they didn't actually share the emissions between the products. And so from an LCA perspective, you would definitely be applying either system expansion or an allocation approach to share those emissions. Now, I'm getting to the end in case you're concerned, Ailey, but another important consideration if you're doing a consequential analysis is the reference land use. And here you need to consider what would have happened without the bioenergy demand. If you're you have an existing production forest, then it's likely that it would be harvested anyway, and with the residues left to decompose. But another potential reference could be that it would be converted to a conservation forest. And you also need to consider, if you're using biomass residues, what the fate of those residues would have been. If it was forest residues that were left on the forest floor to decompose, they might decompose quite slowly in a boreal environment, or they might actually be combusted to enable preparation of the next planting. That's what happens in Australia, otherwise we have a major fire risk. If, on the other hand, they were residues that were end-of-life wood products and they would otherwise have gone to landfill, research, including by some of my colleagues, has shown that wood products last a really long time in landfill. So you're not actually displacing an application that would have returned the carbon to atmosphere. And in fact, there are now CDR methods that rely on digging holes and burying logs. If it's a crop residue, it may have been combusted and returned to atmosphere immediately, or it may have been retained for soil protection. So this is the summary of our standard methodology, showing how the general approach is that you're comparing your bioenergy system with a reference system that captures the reference land use and the reference energy system. And we're suggesting it can be relevant to look at more than one scenario for your reference system. In the paper, we provide a checklist to help you to choose between all those different options that I've been through, depending on whether you have a more attributional or consequential approach. And so the key messages, just to summarize here, are that the methodology really does have a strong influence on the results. Some of the important things are the system boundary and the reference land use and energy system. Choosing the right functional unit, and if your system is a BECCS system that's producing CDR as one of the services, then that may be the relevant functional unit for your system. You need to choose the methods that are consistent with the goal of your study, and you need to interpret it appropriately. So our recommendations are that if the goal of your study is to inform policy development, you should be applying a comprehensive analysis that considers indirect effects and applies the consequential logic. I've mentioned already the key choices that you need to make consistent with your goal. And we do suggest that you provide as much data as possible. One of the useful things about that paper that I showed was that they had supplementary information with all their life cycle inventory. So I could recalculate for different allocation methods. And so that really enhances comparability if you provide that much information. There is my email address. If you're interested to ask any questions, I'm happy to answer them. And the paper is now published. So I'll hand back to you, Ailey.
Fantastic. Thank you so much, Annette. That was a brilliant presentation. And you have given us a lot to think about. I think from the important role of BECCS and bioenergy for climate change mitigation, the complex range of bioenergy technologies that exist, and critically, as the focus of your presentation showed, the many possible variations in methodologies and assumptions that can be used to quantify the impacts of these, and how this can result in quite varied results and conclusions, which can be confusing for policymakers and many other key decision makers. So I'm sure this will stimulate questions in the Q&A, but whilst the Q&A starts to come to life, I would like to turn to our panel now. So I invite Stefan to also turn on your camera. Thank you. And let's explore some of these themes in more depth. So I'd like to start by discussing the theme of aligning evidence with decision maker needs. So the question is, are there areas where current LCA practices still fall short of what decision makers need? For example, in communicating trade-offs or capturing regional differences, and how do you think this guidance could help to close those? And maybe as a follow-up, how do you see the guidance influencing the way that Bioenergy and BECCS are reported and interpreted for policy or practice? That's a big lump of question, but hopefully some of it will stick. Happy to repeat.
I'll jump in while Stefan's thinking. Well, I think our paper really emphasizes that transparency is important, consistency and coherence are important, and that providing as much information as possible, but recognizing that your result is context specific. So I think just helping policymakers to understand that will be important, because what I find at the moment is that policymakers see a range of different results. They feel it's too confusing. They think we don't know enough because there's so much divergence in the results in the literature, even for apparently similar systems. And so they lack confidence in making policy on the basis of that. We had an example of that actually, I'm not sure how long ago, maybe 10 years ago, when a range of countries had their own different methods for quantifying the climate effects of biofuel supply chains. And they gave very different results for the same supply chains. And so that was presented to our task as a challenge to try to understand why those different calculation methodologies that are applied in different countries gave just such different answers. And so with some investigation, my colleagues were able to uncover that it was really a basis of assumptions, and that if you were able to harmonize the assumptions, there wasn't any difference much between the results. So it wasn't that any of the tools were wrong, it's just that they had made different choices in how, various things like allocation approaches. And that was the basis for the differences. But it was really confusing to the policymakers while there were these differences. And so I think if people follow our methodology, then there'll be much greater consistency when people are analysing the same supply chains. And if they provide all the information, like the whole life cycle inventory, and somebody does want to do allocation in a different way or apply a different system expansion, then they'll have the capacity to do that and have a much greater capacity to understand the result.
Thank you, Annette. Stefan, would you like to add any further comment to that?
Yeah, maybe just very briefly. I think Annette covered it quite well already. I think one of the challenges that we have as LCA practitioners is that very often the systems that we study are super complex, right? And it's a challenge for communicating results. And often, like, the trap that we are falling into is we try to aggregate things and we communicate like single numbers. And I think the presentation of Annette was super useful, basically to highlight some of the points with regards to methodological choices. There can be other uncertainties in relation to data and other things. And probably it's important for decision makers, instead of seeing single numbers, to understand like where are these decisive parameters, right? And to discuss about them. So maybe just to focus on two things that I really liked is, one thing is that very often in the discussion, especially here, for example, in Germany, we use or we see aggregated values on maybe national averages, or if we think about frameworks like CORSIA, you even have global values for single biofuel pathways, where I think this paper clearly shows that there are a couple of, let's say, biophysical factors, climate, soil, forest management, a lot of different things, which will influence your result and can lead to differences in the result from one region to another, right? And I think that's super important to understand that there's no just black and gray when it comes to assessing certain biofuel pathways. And then I think another very important thing that often comes a bit too short in the discussion is the communication of potential trade-offs. So I also like this example of using different climate metrics. So comparing, for example, the outcome of global warming potential 100 with GTP, or even maybe in some cases shorter timeframes like GVP 120 or something, because this can really help also to understand if a certain system maybe contributes to short-term targets or long-term strategies. But I think I stop here yeah, maybe just to highlight those two things.
Thanks, Stefan. And I wonder if, just picking up on, you mentioned uncertainty, and that's a hot topic for me as well at the moment, where we are dealing with systems within LCA that are incredibly uncertain. When you throw the land sector into the mix, where there's so much variation and a lot of that is local, there's just huge uncertainty when it comes to modelling in LCA. Do you have any thoughts on how better, or how we can deal with that uncertainty? in a way that, you know, we can improve, I don't know, the impact of the results of the studies, make them more useful, have the output in a way that can be communicated in a meaningful way to policymakers, rather than presenting, you know, results that look perfectly clear, this is the right route, that's the right route, when actually it really is, it is complex and it's uncertain. So yeah, to summarize that question, how can we better deal with uncertainty, or how can we deal with uncertainty in LCA?
I can answer that in relation to a project that we're currently doing in Australia, which is to provide guidance for quantifying climate change effects for farmers and foresters. And so for those people, the consequential approach is not really appropriate, but we do need for them to understand the uncertainty of the estimates that they come up with. And a lot of the uncertainty comes from poor data quality in their on-site data that they're utilizing. And so we wanted, as academics, for them to be actually quantifying uncertainty, but that was clearly over the top as a requirement for these practitioners and farmers, etc. So instead, we've come up with a kind of a scoring system similar to scoring systems that have been used in LCA for 20 or 30 years, really. But we've adapted it for to enable a score for each of the different components of the calculation, and we're requiring that to be presented with the number so that you can at least convey in a relatively simple way to produce that you've utilized quite poor or quite good quality data. We've also developed a protocol for helping people to identify what are the most high quality sources of information when they're trying to get an emissions factor together, for example. So the application was for feed additives used in feedlots, and to reduce enteric methane. And so the guidance is telling people what would be an appropriate number of scientific studies. How relevant does that scientific study need to be to your system for it to be valid to apply to your system? So I think between those two sorts of approaches, you can help people to capture uncertainty without requiring them to hire a statistician to quantify it.
Yeah, thanks, Annette. Stefan, would you like to add anything further?
Yeah, maybe just very quickly, in addition, I think, well, maybe I have two answers to this, which are a little bit contradictory even. Like, I would say from the perspective of an LCA practitioner, we often live with this uncertainty, and we rather probably see all the different flexibilities that we have in the methodology, maybe not as a bug, but as a feature, because it can really help us also to study super complex systems, right? And deal with lots of different situations. And probably it's also very important to communicate that the result, like the actual number that you get out of a calculation, is one thing, but understanding like which assumptions and methodological choices matter the most is probably on the same level of importance, because you should also probably discuss about those. For policymakers or decision makers, I can understand that this is confusing, and maybe I don't, probably that's a hot topic, but one of the answers to this could also be more standardization. So think about if there are specific examples to what has to be reported as an outcome of the result. So instead of just only reporting a number, maybe there should be extra features that should be mandatory for reporting. And yeah, maybe a couple of additional points regarding standardization, but again, stopping here too. I think we have a lot of questions on the Q&A.
I think that they're great suggestions. I mean, just to probe a little further, what mandatory additions might you suggest, or for additions in the reporting? Yeah,
I think Annette has pointed out some of the decisive factors in the methodology to make sure that we are comparing things that are somehow similar. So functional unit, maybe the choice for the reference scenarios on the land use side, but also the energy side, because they clearly have an impact on the result, right? And you want to make sure when you compare results that the studies used somehow comparable assumptions. So I guess what you want to do is make sure that you're not comparing apples and oranges here. So this is one thing, and yeah, in general, I think when studies use consistent methods, especially with regards to the points that have been highlighted also in the reports, it can help to compare, for example, then BECCS options across regions or even also across different feedstocks, which seems to be difficult sometimes.
Thank you. I'm going to ask one more question, then I'm going to go to the Q&A board because there are quite a few questions coming in now. I'm going to attempt to read a few of those out. But just before I do that, one question, how can this guidance specifically be used to improve confidence in, that policymakers might have in LCA results that they can use for then designing kind of bioenergy policies and other sustainability criteria?
Well, Ellie, I'm thinking that it would be useful to incorporate this guidance into the various standards that are being developed for greenhouse gas quantification. I'm sure you're familiar with the ISO standards and the greenhouse gas protocol, for example. Now they're just about to publish their land sector and removals guidance, but they're in a phase of revising their documents. And I'm not sure if you've noticed, but actually ISO and GHG protocol are working together now on the greenhouse gas quantification standards for organisation, product and project level. And so I think there's potential to include this guidance in those standards. And so then you'll have an opportunity for certification against it. And that's one way to give confidence when we're talking about the routine application of these quantification methods. When it comes to, you know, the big research projects that are modelling the whole world and trying to figure out what the indirect effects are of bioenergy supply chains, I guess that's when it becomes more complicated because the models themselves are large, the results are complicated. I think the important thing is to model multiple scenarios. A couple of people have asked in the chat about how do you get the right reference and know you've chosen appropriately. And so I think the paper helps to highlight that there are, I guess, right and wrong answers of what is an appropriate reference system, and that it's not clear-cut what the correct one would be, but modelling multiple references can really help to understand the range of different outcomes and overcome that, I guess, trap that if you just model one system and you come up with one number, then the policymakers will think this is the number for that supply chain versus that other one, which is, of course, a false idea of precision. So I think, yes, the important thing is to follow something that you can identify as a published standard and then provide multiple scenarios so that people can understand the full implications of the different supply chains that are being considered.
Thanks, Annette. And now I'm looking through the Q&A.
Can I jump in and answer some that I've spotted?
Yeah, please do, because, yeah, please do, Annette. It's amazing, quite a lot.
Someone's asking about sustainability issues, and of course our task does look at sustainability issues much more broadly than climate change. This particular paper focused on our climate change methodology, but we're also developing metrics for looking at broader issues of sustainability, including biodiversity. And this is, of course, a really significant and important consideration when we're talking about what is appropriate biomass. And I think most policies would be protecting old growth forests, I think is mentioned in the chat, from use for bioenergy. So certainly our task is considering it, and the policymakers are considering it. I noticed that Philip Jonsson is asking, have we actually used the methodology? And I was thinking maybe Stefan could answer that, because Stefan's recently led a project that did apply the methodology for a number of different supply chains, but I'm not sure if there are any of the ones that Philip has asked about. He was asking about BECCS systems.
not particularly for BECCS, but for forest biomass in general, I would say. So maybe just to illustrate this, we are currently an ongoing process here in Germany about how do we want to assess the use of forest biomass for energy purposes in general. And there's an ongoing project where we discuss a lot of the aspects that you also raised in your paper, Annette, and things related to, especially related to the definition of reference systems, because that seems to be highly important for policymakers to basically understand against what are they comparing the use of forest biomass for energy. And I think there are a couple of counterfactuals that we are discussing with regards to the reference land use, scenarios without bioenergy, scenarios even without any forestry management. So, and then also on the energy side, I think there's a lot of discussions about whether some of the, let's say, more traditional and old counterfactuals for the energy system are still valid today, given that in the different member states in the European Union, but also across the world, we already have progressed a lot with regards to the share of renewables and even bioenergy in our energy system. So that requires, in some cases, a more dynamic approach to understand what the reference system should look like. So yes, to answer this, we have taken a lot of different elements from that guidance to inform that discussion, I would say.
Thanks, Stefan. So we've talked a lot about how this guidance is relevant for policymakers and generally for practitioners. So if we focus a little on industry application and impact, how do you see this this guidance being used in practice in industry, and how do you think it might impact the development of sustainability strategies or market positioning in industry?
Yeah, I notice people are in particular interested in how it aligns or otherwise with the EU CRCF methodologies. And I don't know the detail of that, I'm afraid. But I notice there's a comment about it not including ILUC. And I guess to be consistent with our methodology, what we're saying is that when you're designing the system, like determining which feedstocks, which biomass supply chains are going to be promoted or accepted within a particular policy, that is when you need to be doing the full consequential approach and looking at the indirect effects. When it comes to an individual industry participant demonstrating that they do or don't meet the requirements of the policy, I guess our methodology would suggest that an attributional approach, which doesn't consider the indirect effects, would be the appropriate thing to be applying there, because here you're encouraging the industry participants to look at their own supply chain that they have control over and to make appropriate choices to minimize the emissions associated with their particular activities.
Thanks, Annette. Stefan, is there anything else you'd like to add?
Yeah, maybe more in regards to your question, like the implication for industry, I could maybe think about a couple of things here. So I think what could be relevant from the industry side, basically, first of all, it's important to understand like in which kind of technologies you want to invest, right? So is it a good idea from a climate perspective to start retrofitting existing biomass plants, which use forestry residues, for example? And I think the paper can help to build a robust method and framework for this assessment. And then I think one thing that is also super relevant for the industry is then basically understand how a certain supply chain could even be optimized. So you want to understand like what are the hotspots and the drivers in your results. Are there any ways to use alternatives to bring down your emissions over the value chain? Usually here we also use life cycle assessments, and I think here also again the guidance can help to increase the level of granularity and understand a little better what the hotspots are. And then maybe the third area that could be important is regulatory compliance and things like market access, right? So usually, like within the European Union and also in some other parts of the world, we see that policymakers also introduce specific sustainability requirements or things like emission thresholds, which have to be met by the operators of such facilities. And I think also here it's important to discuss about how these methods that are being used to calculate whether the requirement is being met or not are designed, what they can include, and how do you actually set them up. And also maybe here the guidance can help a little bit to build some, let's say, robust frameworks for the calculation.
Yeah, thank you, Stefan. So as maybe a final theme or question before I round up, as we're approaching towards the end of the webinar today, do you see any possibilities of any resistance to using the methodology as it's proposed, or do you think this is generally fully welcome? From my perspective, it's entirely fully welcome. But do you foresee any scenarios where some might not perceive it that way?
Well, we had an interesting time in pulling together the paper because we had a fairly divergent group with wide range of experience amongst the experts writing the paper. And we did have, as I indicated, a strong focus on the consequential approach. And I suppose we wanted to be able to discuss both approaches, the consequential and the attributional approach. And we did have a divergence of opinion as to whether the attributional approach was even an appropriate thing to include within the paper, because I guess people are concerned that in an attributional approach, you are missing the indirect effects, and they could be quite significant. On the other hand, people were also looking at our long list of aspects you need to take into consideration. And I didn't actually go into all the details. We have said that if you have a system that is likely to be changing other climate forces, like short-lived climate forces, soot, the albedo, then you should really be looking at those as well. And of course, then it becomes really quite complex if you're trying to take all those climate forces into consideration. And so amongst our group, we had some, I guess, people suggesting, well, maybe you look at the list and you consider which are the most appropriate and important for your particular system based on which the factors that are most impacted by your system, but also how important is the decision that's going to be made according to your study? Is it something that is informing a small industry's choice between products, or is it something like the EU devising a policy that is going to impact thousands of people and businesses? So I guess it's choose the appropriate methods for considering the significance of the decision that you're making, and we certainly did have a lot of people suggesting that the attributional approach, using an economic allocation, which I guess is the most simple to apply, is actually the method that would work best for industry, because then they would have the most confidence in the numbers, because I guess some balk at the consequential approach due to the fact that you're looking at what does your co-product displace in the market. And so what it displaces changes over time as markets change, as prices change, as different products become available, even as consumer preference changes. And so this lends uncertainty, I suppose, to people making a decision to invest in a plant. They really need to know, is their is their bioenergy product that they're planning to produce, is it going to meet the requirements? Is it going to meet the thresholds? And if it's subject to market fluctuations, this could be quite problematic for going to the bank to get a loan. So in circumstances like that, an attributional approach based on a simple economic allocation can really be more straightforward and comparable for the industry players. But I guess the academics balk at it because it could be missing some really important indirect effects. So the message is that policymakers should be thinking about the indirect effects when they devise the policies, and then let business get on with it, with the bits that they can control.
Brilliant. Well, I was going to ask for a closing thought on what your kind of single action or next step, but I feel like that was a really nice summary and kind of important message to close on for you, and so I will ask for a closing thought from Stefan. The question I was going to pose was, what single action or next step do you think would most help ensure that this guidance and this approach has real world impact, whether it's in research or policy or industry?
Yeah, I think Annette has explained very well, like the process leading up to the publication, right? And I think now it's there and it's brilliant. But I think what could be a super follow-up activity is maybe to consider it kind of a living document, or even something like a living guidance platform and so on. And maybe we could think about further elements that we could add to this, like further decision support tools, like flow charts, or ways helping people to apply it. And maybe even something, addressing one of the comments there, something like a case study library where people actually used it and publish their results in a transparent form, which could also help other practitioners to apply it. So I think it would be great if we not stop with that specific paper, but also bring it into some kind of other more living and interactive form that could be maybe something to take up for IEA Bioenergy.
I think that's a super suggestion and a great closing thought. We do have a couple of minutes, Annette, if you do want to add a further thought before we close.
I guess maybe just also to say that our life cycle assessment approach focused on particularly on a product and a single supply chain can be a bit narrow, and it is important to also look at other approaches like energy systems modeling in order to inform policy development. So our approach is one of the important sources of information to inform policy development when we're looking at what bioenergy would be helpful for climate change mitigation.
Brilliant. Well, thank you so much. I thoroughly enjoyed the presentation and the discussion. I hope it was interesting for everyone listening, and appreciate everyone for joining today. And thank you also for the CMCC for hosting. I pass back to the hosts of the webinar if they want to say a final close, and thank you all.
Yeah, thank you very much, everybody. Very great discussion and presentation. We are happy to have you here, and as I mentioned also in the Q&A, the presentation and Q&A, everything has been recorded, and we are gonna share it soon on our YouTube channel. So follow our CDR stakeholder forum or also our YouTube channel, and you can watch this video again. Thank you very much, everybody, and have a nice day.